Okay, the problems are here. Yeah, that's kind of distracting. Okay, so what's the slope here? Well, to get the slope, you can use the equation, but I've recommended that you draw a triangle and get the rise and the run from that, so you understand what the slope is rather than just a formula. Now, maybe you do understand that, and kind of up to you, but there will be problems on the test, for example, where I ask you to show me that triangle, okay, and use that triangle. So triangles just consist of the line between the 2 points, line segment between the 2 points, and either a vertical or horizontal arrow, or vertical and horizontal arrows to take it from this point to this point. Okay, so it's this way and this way. Now, if it's this way, this arrow has to point this way. It can't point back this way because it takes you from here to here. It doesn't take you from here to here. Does that make sense? So this arrow takes you from here to here. This arrow takes you from here to here. It doesn't take you from here to here. All right? That should be obvious. Make sure you understand that. So now you got the rise. What's the rise? Well, these are intercepts. It's pretty easy. The rise is from 12 down to 0, right? That would be negative 12. And the calculation is this point minus this point. The y coordinate is 0 minus 12 equals negative 12. So put that calculation in parentheses. The run is clearly 16. You're not x equals 0, x equals 16. Okay? And in parentheses, 16 minus 0 equals 16. So the slope rise over run. You divide the rise by the run, you get negative 12 divided by 16 equals negative 3/4. And I put a box around that. Now you're not required to put a rectangle around it, but it's a good idea to have the slope labeled as above sloping line. And you put a box around it so you don't think that the distance here is 3/4. It's important to distinguish those things. All right, anyhow, so you've got the slope. Now, what do you do with that? Well, the equation is y equals mx plus b, right? There's your slope. B is your y-intercept. So y equals negative 3/4 x. And the y-intercept is y equals 12. So that's going to be plus 12. There's your answer. Make sense? Okay. Now that's not the problem I would have started with, but if you saw it and knew immediately what to do, and many of you I'm sure did, I'd start with that. I'd start with this. Okay. I just read through them and say, well, that was obvious. Okay, this has y equals mx plus b. M is your slope, so that's 2/3. B equals 5. So y equals 2/3 x plus 5. There's nothing to it. if you know what mx plus b means. And even people who, for one reason or another, didn't get to the assignment, pretty much remember that, because that's real standard in any course that's a prerequisite for pre-calculus, or at least in the algebra 2, and probably in algebra 1. Okay, I'm not exactly sure whether this is an algebra 1 or algebra 2. And I have vague memory from 100 years ago when I took the course. Okay, but of course it did slightly changed since then. Okay, now let's go ahead and do this. And let me change colors so we don't confuse solution for one, the solution for the other. Where is my chalk? There. I never noticed where I lay it down, and I'm really bad at finding it. Okay. This one? Well, I start with a triangle. And up here, I would ordinarily have completed the triangle. Kind of change the thing a little dark. You use this one color, just sure you shade the triangle. You do put an arrow on this one because you are going from this point to this point, although that doesn't matter once you get the rise to run. You're going to get the slope right. Okay, so well, you've gone from x equals 3 to x equals 8. So the run is 8 minus 3 equals 5. The rise goes from y equals 7, y equals 11. So the slope and I recommend you write all this out. It just takes seconds to write slope equals rise over run. And run equals what? Where you're going minus where you are. Horizontal. And the rise is where you're going minus where you started on the vertical direction. So I can put arrows in these just to make sure everything's in the right direction. And I get 4 over 5. Put the box around that. And there's the information I need to get my slope. Okay, so I'm not going to write m equals slope equals 4 is because people pretty much, at least after they've seen this once as a refresher, remember that m stands for slope. Okay, that's pretty, some people are pretty familiar with. Okay. So right now we know that y equals 4/5 x plus b. Of course, we still got to figure out b, but we've made some progress. Okay. Now I'm going to digress for a second on the idea that you need to be writing out all your solutions, okay, in your notebook. Now, in my pre-calculus class, I require people to upload a picture, okay? What I'm saying from those pictures, sometimes I just see some stuff on a page and it hasn't addressed all the problems. You should be writing out every problem. When you write it out, you reinforce it, okay? Yeah, if you think you don't need to reinforce it, think you don't need to write it out, just write the problem number and say obvious. Then I expect it to always be obvious. Okay. And sometimes it will be like, y equals mx plus b is pretty obvious to most people, even right now. Still, if you're writing out a solution to a problem like this, you want to start with the triangle. Y equals mx plus b, m equals 4/5, so that this is so. That's a logical statement. These two things go together to give you this thing. So is important. Write out the logic because you will remember it better and you'll be more likely to be logical in other solutions and analytical. Okay? I see way too much of just scattered calculations. Some people are pretty good at it, they get by, but they usually don't do extremely well. Of course. Especially if you're in a curriculum that involves calculus, one form or another. You want to be as rigorous as you can. So, okay? It'll benefit you in your Math 161 so that your Math 161 will better benefit you when you take calculus. I see people coming out of calculus courses that never learn how to learn anything. And they struggle, even though I know that in those courses, and that includes when I teach the course, certain points are really emphasized, but they just don't stay. They don't stay with people. So be very meticulous in the way you write these things out, especially if you have a calculus course in your future. And even if you don't, understanding flow of your thinking is going to be beneficial to you someplace, even if you never take another math course. Get better at your thinking. I had this experience in college. Some of my buddies and I, there was a guy who had a red belt in karate and he was teaching a few classes, just informally in the gym. Okay. And I took a few of those classes, learned to make certain moves quickly. The thing I noticed was then when I was playing basketball, my hands were much quicker. Okay. Just by learning to do those karate self-defense movements, get transferred over into basketball. Okay. Well, they're both physical sports. So you would kind of expect maybe a little bit of transfer, but by analogy, stuff you learn in a math class, thinking process and the specificity of the thinking and the analytical aspect of your thinking transfers over into many other things. Okay? There are things that I am much better at because of all the mathematics I've done in graduate school. So, yeah, I'm in graduate school. And then teaching, even though I'm teaching stuff that I've known for well over 60 years. And early in my education, by the time I was a sophomore, okay, I spent 5 more years in math, okay? But even teaching the multivariable calculus of the differential equations course, which is the highest level course to teach. In the process of trying to communicate those courses, I understand stuff better. So when I'm looking at the development of Einstein's general theory of relativity, I understand things better now than I would have coming out of graduate school back in the days when I was actually kind of smart. Okay. So, just personal, but just an example. The point is that what you learn here, if you do this in a coherent way, is going to be beneficial to you. So, and if you're going to take additional math, it's going to be extremely beneficial. Okay, back to the problem. We easily, given the coordinates of the 2 points, figure out the slope. Now that we've got the slope, we still have to figure out B. How do we do that? Well, we just take one of the points. They're going to take you to this point or this point, right? So everybody give me a thumbs up or a thumbs down if you want to choose this point. It makes no difference. Doesn't matter if your thumbs are up or down. Okay. Okay, well, I don't see a lot of those. I think I've got a majority of thumbs up, at least 4 people. At one point or another, put their thumb up or down. Okay. So we're going to choose this point. Arbitrarily choose x, y equal A11, coordinates of the second point. Okay. Equation must work. X equal 8, y equals 11. So what? We plug in 11 for y and 8 for x. Now you might just remember, plug in 11 for y, 8 for x. If you write this out, again, you're going to learn more. You're going to learn it better. You learn to write this out, you'll also become a better writer. Okay, that'll take you in many courses. X equals 8, y equals 11. So if x is 8 and y is 11, our equation becomes 11/5 equals 4/5 of 8 plus b. Okay. And it's got to work for those numbers. This equation has to work for these numbers because these numbers give you the coordinates of a point on the graph. Okay, so we solve. For b. Well, that's very easy. First thing I'm going to do is if I have a denominator, is multiply both sides of the denominator. And you would want to write that out. I don't have room to write it out. You want to multiply both sides by the denominator to clear the fractions. Or at least think of it. And make sure you understand why you're doing that and that's why it works. So 5 times 11 is 55. 5 times 4/5 is 4. And since you're multiplying the whole side by 5, you also got to multiply the 5. About the b by 5. Okay. Now I could have multiplied the 4 by the 8 earlier. I'm going to have to do it eventually. So it's kind of a matter of choice whether you do it before or after you multiply the sides by 5. I'm emphasizing the first thing we want to do when we see a denominator is get rid of it. Okay? As long as you can do it correctly, you're going to. So we'll get 55 equals 32 plus 5b. I don't have room to write out the rest. Let's subtract 32 from both sides. Gives us 23. So we're going to divide by 5. We get b equals 23 plus 5. Okay. So that our equation is this. Now, ordinarily, we would check this. Take the coordinates of this point and plug them in. If it works, then chances are very high that you did it right. So if I put 3 in for x and 7 for y, if I get 3 here, that's going to be 12/5. 12/5 and 23/5 is 35/5. And 35/5 is 7. So y would be 7, and that's what it better be. So Their cause for celebration. I actually did this thing without making some stupid careless error and screwing it up. Okay. And you see me do that. You see me make just little careless errors. Just explaining and my brain doesn't connect to something. So I check it and then if necessary, I fix it. Okay, on this one. I'm not going to write out all the logic because I don't have room, but I would want you to write out as much logic as you can. So we have now right now some of it. M equals 3/2, so y equals 3/2 x plus b. I think it's a good idea right there. It doesn't take long, it's really easy. If you're in a big hurry, well, I know you're going to skip it, but don't skip it any more than you need. Try to give yourself time to do this right because you'll learn it faster, even though you're taking more time on the home and you do better on the tests. Okay, y equals 6 when x equals 3. Okay, let's check against that. So 6 equals 3/2 of 4 plus b. Well, 3/2 of 4 is 6. Subtract 6 from both sides. You get b equals 0. So your equation is x plus 0, but that's just 3/2 x. Okay. Try to do your work as much as possible in the way I'm recommending. Again, it'll have all kinds of benefits for you. Among others, it'll make you more likely you're going to do well in your pre-calculus course. Okay? And be better prepared for subsequent courses. Or if nothing else, just be able to think more clearly and to write things out more clearly in all kinds of situations. Okay. Situation is your speed is increasing linearly with time. T equals 5 seconds. Your speed, which I indicate by V for velocity, even though, well, I can't call it a velocity, but right now it's just speed. It's 10 miles an hour. And when T equals 12 seconds, that means that time is 12 seconds. Your speed is up to 20 miles an hour. Okay? Put that information on a graph. That's a skill you might or might not have. I'm going to give you a couple of minutes to show off. And depending on what I see, I'll say what I have to say next. Okay, so we're still writing out the question. It could be that that's part of the process of processing the question for you. Okay, I'll leave it to you to make that judgment. I think for most people, the thing to do is slap down a graph, put a couple of points on it. Okay, so most people have a graph. Some people are processing by writing out the question. That's okay. Can you visualize what's going to go on the graph? Well, when T is 5 seconds, V is 10 miles an hour, right? So let's see, where would we put 5 seconds? Well, we put it on the t-axis, right? And then we kind of look ahead, we're going to have T equals 12 seconds, so our time had better go up to 12. So don't want to put 5 here. That's when we erase all this and draw along our axis and go off the edge of the board, okay? Or the edge of your paper or whatever. So I'm going to put the bigger number down here, 12. And T is in seconds. something you want to take a few seconds to write out. You can abbreviate it SEC. And velocity is in miles per hour. So we don't have to put 12 seconds here. We just put 12 because now we know it's seconds. And then we put 5 over here. You know, a little less than halfway between 0 and 12, right? 6 would go about halfway here. So 5 is a little to the left. I think I may have it a little too far to the left. That's okay. All right. Unless you're trying to use the graph to make accurate predictions. Just use the graph to represent the line here. Well, the linear function. Okay. So now when t is 5 seconds, v is 10 miles an hour. And then we have a v up to 20 miles an hour. So I guess we better put maybe 20 right here. Not to label it to the left. Label the 10 to the left. Being a little inconsistent. Okay. So when t is 5 seconds, v is 10 miles an hour. So I'm going to write a point that corresponds to 10 miles an hour. I'm going to write this line and say this is 10. The dotted line is v equals 10. Everywhere in this line, v is 10. Okay. And I've got this 5 here, t equals 5. Everywhere in this line, and where those lines meet, both of these things are true. So this point then has coordinates 5, 10. And then t is 12, v is 20 miles an hour. Well, here's the vertical line, t equals 12 everywhere on this vertical line. The horizontal line, v equals 20 everywhere on this line. And we have this point, which is 12, 20. So we understand how to do this? Okay, that's the first thing I'm recommending that you do when you have a problem in section 5.2, where you have a bunch of situations. In every one of those situations, you're going to want to go to a graph and put all the information you have on the graph. Now, next thing I want is what's the equation of the linear function v of t? That's not v multiplied by t. You don't multiply v by t. Okay? In this situation, that's a function notation. So if I give you a value of t, you replace t here, and you have a formula for v of t. So what's the equation of linear function v of t? V of t equals what? Well, I'm not going to try to dig this answer out of you. It's something you might not think of. You might skip to something else, and you might still be a little confused. You have v of t is going to equal mt plus v. Now, we're not using x for time. It's less clumsy to use t for time. We'll kind of automatically use x for most functions. But if it's a function that involves time, and so many of them are, use t. And sometimes you use it even a different letter that better represents whatever goes on this axis. Okay? Anyhow, you have v of t equals mt plus v. What's m equal to? Well, go ahead and work it out. We're going to follow the same strategy we did on a previous problem where we had 2 points on a graph. What's the first thing we did? I'll even put that one up there where you can see it. Okay, now everybody is making progress on this. Okay, M equals what? I'm going to leave it as a question. I'm going to say now I'm going to just kind of cut to the chase. Your rise is going to be from 10 to 20, right? So it's going to be 20 minus 10 or 10. And your run is going to be from 5 to 12. I don't recommend that you write this out as a formula. I recommend that it comes from labeling fundamental triangle, where you show, for example, as we did here, run is 8 minus 3, which is 5. Rise is 11 minus 7, which is 4. And these don't come from symbols that you remember. They come from what you tangibly see on the graph. Tangible usually beats symbols. Although if you're really good with symbols, I can respect that, okay? Okay. So, and this is then 10 over 7, right? Okay. Now find B. You are going to have to write an equation, solve it. There's no other good general method of finding B. You could use similar triangles, yeah, but I'm not even going to mention that, except I mention it. Okay. Okay, so what I'm saying out there looks pretty good. Find B, pick a point. Well, we picked the second point, the point to the right first. On the first example, we picked the point on the left. T equals 5, B equals 10. Actually, there's some I have to do the first one, because we did do it before I debated about that. So, first thing you got to know to find B is the equation y equals 10, 7, 6 plus B. So I think everybody, I don't know if everybody wrote that down, but it's real important to write this down. So if you didn't, and if your solution is starting to go haywire, take a lesson, write this down, because that's a point of reference, right? Now, when it's not y and x, we're using B and T, so I should make that a B, make this T. Right, here's my equation that didn't look up there, yeah. So I wrote down something that might be confusing. the equation is this, and now it's this. Okay, so anyhow, now that's the leftmost point. Probably can't read that. That corresponds to a point on the graph, right? But it's also right there in the information. So you take it from either place. Since we're kind of focusing on graphs, I recommend you look at the graph, then remind yourself how they came from the statement. Okay, so we get that right now, the right words here, but I'll say it anyway. Okay. Get 10 equals 12 steps, isn't it? No, it's 10 steps. Yep. Yep. 10 sevens to 5 plus B. Then you solve it. Now you write out some details. Right here, I'm just going to do 5 times. And that becomes 50. And we're multiplying by 7, not 5. Sorry. Because 7 over 7 is 1. We just end up with 10 times 5, which is 50. And on the left, 7 times 10 is 70. So we get 70 equals 50 plus 7b. Some dots fill in the blanks, but you end up, I believe, with b equals 20 over 7. Everybody get that? Okay. Okay, so I'm going to kind of confirm that. I would ordinarily check it, run short on time. So if that's correct, I can check that in my head. Does that work for 12 and 20? Well, if you got 12 here, you got 144 over 7. And 20 over 7 is 164 over 7. And that doesn't seem to work. That'll work better if I put the right number here. It's 10 sevens. Let's get up on the wrong side of the bed. Do worse than usual. Okay, so okay, 10 sevens is 12, 120, add 20, you get 140, and divide that by 7, you get 20. And that's what you ought to get from this point. So I tend to believe the solution. All right, now I want to focus for the last few minutes on the meaning of this slope, because it's kind of the most important point in this section. Okay. Okay, so slope. It's rise over run, but the rise is actually not 12, not 10 over 7. It's 10 miles per hour over 7 seconds. Okay. And I could write that down as, I go ahead and divide the 7 into 10, I get about 1.4, 0.43. Okay. Those 3 significant figures. If I want to express it as a decimal, I could leave it 10 seconds, but 1.43 is going to make more sense when you think about the actual meaning. And what do we have? We have miles per hour over seconds. one unit over another unit is this many units per this, okay? This means we speed up by 1.43 miles per hour every second. Okay. And we put a word on it. Use words to describe. This is called the average rate. Average rate of change of speed. Now that's all open math is going to ask you to say. Well, it's not just the average rate of change of speed because you've also got to acknowledge that it's per second, right? And I say per unit of time. And or abbreviate this, it's the average rate of change. I use ROC for rate of change. I use with respect to time or abbreviating it really a whole lot. ROC for average, for rate of change. WRT for with respect to. Okay. So I kind of advocate understanding this idea of average rate in terms of this example. And you're going to see a bunch of examples and they're going to ask you a bunch of things. What's this average rate? And if the average rate is this, what's the slope and so forth? They're going to leave out, and I kind of disagree with them. They're going to leave out with respect to, okay? And that's very important. This is the fundamental idea behind first semester calculus. Most fundamental idea you're going to see at the beginning of your calculus course. And there are a couple of other fundamental ideas that are really important too. The idea of a limit and stuff like that. Okay, and we'll talk about that a little later, about a month or so. But this, average rate of change of one thing with respect to another. That's basically what a derivative is, and everything you do the first couple of months of calculus is aimed at derivatives. Okay? If you don't have derivative, if you're not going to be taking a calculus course, this is maybe the last math course you're going to take, so maybe statistics. This is still a really important concept. Okay? What's the average rate at which bacteria was growing in that tuna capsule my wife made 3 weeks ago that I ate for breakfast this morning? That wasn't 3 weeks ago, it was 3 days ago. So the average rate of growth change of the bacteria in the refrigerator is low enough that I'm probably going to live. Okay, hopefully without any symptoms. All right, average rates are really important. You can use them to predict things. You can use them to understand processes that you wouldn't have a clue about otherwise in your everyday life. So really important thing, give it the attention it deserves. Give it the attention you deserve to give it.